In today's daily dose of math, we're looking at the inverse function compared to the inverse of a function. Okay, so that's pretty close, but unfortunately in the Secondary 3 algebraic modeling course that I teach to some of my students, they are responsible for knowing the inverse function quite well, and they also have to know the inverse of a function quite well. So the names are so similar, it's a little bit unfortunate, it can be confusing. So let's go over what these mean. The inverse function is our pizza function. It is in the form y equals k over x, where k is a number. And I always remember it with the pizza example. We have 2 medium pizzas, that means 12 slices. Our function will be y equals 12 over x. If x is the number of people who are going to share the pizza, we plug that in. With 3 friends sharing pizza, y is equal to 12 over 3, which is 4. That's the number of slices each person gets. It's a simple function that's easy to use, and it's called the inverse function. But the inverse of a function means something else. It means, what will that function look like if you draw a reflection of it across the line y equals x? That's one way of looking at the meaning of it. It also means, what will that function look like if you replace the x and y, if you switch their positions, and then graph the result? If you're doing the inverse of a linear function, it's not that confusing. The inverse of a linear function, we are going to draw the reflection or switch the positions of the x and the y. So if I do that, I have x equals 3y minus 4. I can isolate my y with algebra, and I get the inverse of the original function, which will be y equals 1/3 x plus 4/3. If I graph the inverse, it's going to have a y-intercept of 4/3 and a slope of 1/3, and it's going to look like this. If I graph the original function, it has a y-intercept of -4 and a slope of 3, and it's going to look like this. What I'll do is I'll draw the original in red. And then you can see that although it's not drawn perfectly, the inverse is a mirror image, a reflection across the line y equals x of the original function. When we are asked for the inverse of a function, though, it's not always going to be the inverse of a linear function. We can be asked for the inverse of an inverse function, and that's where this starts really seeming quite confusing. The inverse of an inverse function is going to be a reflection across y equals x, and it's also the function you get if you switch positions between the x and the y and graph the result. If I switch the x and the y, and then multiply both sides by y, these cancel. I have xy equals 10. And then if I divide both sides by x, these cancel, and I have y equals 10 over x, which is the same thing I started with. So that means that the inverse of this inverse function is itself. How is that going to look on the graph? Graphing the original with red, I'm going to have a function that's going to look something like this. And then graphing the result, which is the same with white, I'll try to overlap them enough, and you can see, well, it is still true that this shape is its own reflection. So when you do a reflection across y equals x of the original function, It just lands in the same place that the original function was, and here's why. Here's the algebraic reason why. So the bottom line of this lesson is we have a potential confusion because we have an inverse function and we have the inverse of a function, and just to be as confusing as possible, we can be asked for the inverse of an inverse function. If you know these examples, then I don't see how you can be confused. This is today's Daily Dose of Math. Don't forget to like this video, and if you're not subscribed already, click on the subscribe button.